Anytime a chemical or physical reaction occurs, energy is involved. And let's look at energy. According to physicists, the most basic definition of energy is the capacity to do work. And work has a technical definition of application of a force on an object over some distance. Now, at this level of chemistry, we're not really going to use work as our definition of energy. We'll look at other classifications of energy. But before we talk about that, let's look at the units of energy. The metric units of energy are joules, symbolized by capital J, and chemists often use kilojoules to describe the amount of energy flow in a chemical reaction. Another unit you may be familiar with that is used for energy is calories. So this slide has the type of energies that are most relevant to chemistry at this level. At the top we have kinetic energy, and that is the energy of motion of an object. And that is important, for example, in different states. So the molecules of a gas are moving much more quickly than the molecules in the liquid or solid state. So gas molecules have higher kinetic energy than the molecules in the solid or liquid state. Also, electrons are always moving, and they're moving really, really quickly. So electrons have kinetic energy, as do the protons and the neutrons, but they're not moving as quickly as the electrons. Heat energy is an energy flow from high temperature to low temperature, and most chemical reactions actually release heat energy when they occur. Potential energy depends on the position of objects with respect to one another, and one type of potential energy that is really important for chemistry is the potential energy that comes from the attraction of unlike charges, such as positive and negative charges being attracted to one another, and the repulsion of like charges.